Okay, let's have a go at 21 then. Here's our equations. Let's write out the augmented matrix. 1, 2, 3, 6. 1, 2, 3 and a 6. Yeah? Minus 2, minus 4, minus 6 and a minus 12. And then a 3, 5, minus 1. 3, 5, minus 1 and a 7. Okay, good. So let's just simplify this now to get it in upper diagonal form. So we've got the 1, 2, 3 and a 6. Let's do row 2 plus 2 row 1, yeah? Row 2 plus 2 lots of row 1. Minus 2 plus 2 ones are 2. Minus 2 plus 2 is 0, that's why we're doing it. Row 2 minus 4 plus 2 2s are 4. Minus 4 plus 4 is 0. Minus 6 plus 2 3s is 6. Minus 6 plus 6 is 0. Minus 12 plus 2 6s are 12. Minus 12 plus 12 is 0. So the next row now, row 3. Let's have a go at that one. Row 3, take away 3 row 1s, yeah? And that will become 0, won't it? 3, take 3 of those. 5, take 3 of those, which is 6. 5, take 6 is minus 1. Minus 1, take 3 of those, which is minus 9. Minus 1 minus 9 is minus 10. 7 minus 3 6s is minus 18. 7 minus 18 is minus 11. Okay, let's just swap row 2 and row 3 around then to make it look easier on the eye, isn't it? And we get 0, minus 1, minus 10, minus 11, 0, 0, 0. And it's in upper diagonal form now as well, of course. So that's good. So now we've reduced 3 equations in 3 unknowns to 2 equations in 2 unknowns. These can be written as equations then, so let's write down what we've got here. We've got x plus 2y plus 3z is equal to 6. And we've also got minus y minus 10z equals minus 11. So, okay, so these represent planes in 3D space, and we can see from the way they are that this is not a linear combination of this, so they're different planes. They're not parallel planes. So because these aren't parallel planes, they must intersect in a line. So we're looking for a solution which is a set of points along a line. Yeah, we can see that this would need this 1, 2, and 3 would need to be a linear combination of what would be here below for the planes to be parallel, and it's clearly not. So, okay, then because we've made that observation, we can parameterize. The easiest way to parameterize this then is to let z equal a parameter. Let's call it lambda. Then, what's y going to equal? Well, let's move the y over there. And then I'm going to also move the 11 to the other side. So the y went over there and I wrote it from right to left. The 11 moved over here to become a plus 11. The minus 10z can stay where it is, and I wrote it from right to left. Z is lambda, so y is equal to 11 minus 10 lambda. And also then we can get x. So let's give ourselves a bit more room. So there's the x. Also x plus 2y plus 3z is equal to 6. Yeah? So we've got x is equal to 6 minus 2y minus 3z. And that's equal to 6. Take away 2y. 2 lots of 11 minus 10 lambda, yeah? Minus the 3z, and z is the value parameter lambda. So what have we got then? We've got 6. I'm going to expand this bracket now. It's minus 22 plus 20 lambda minus 3 lambda. So x equals then, we've got 20 lambda minus 3 lambda is 17 lambda. 6 minus 22 is minus 17. No, it's not. It's minus 16. Yeah? So there we are then. So we can just summarize that then. So what have we got? Z equals lambda, y equals 11 minus 10 lambda, and x equals 17 lambda minus 16. And we've parameterized the solution set here, which represents a straight line in 3D space. Okay then, so there's the process. We'll probably do a few of these now to see how we get along with them. Alright then, but we basically, I'll just say a quick word about it. These three equations here represent three planes in 3D space, and we reduce them to the equivalent of these two planes in 3D space. Non-parallel, because this row is not a linear combination of this, so we couldn't reduce it to one row of zeros at all. One row of the equation, so we ended up with a solution that's a line. Okay then, and we parameterized it in the easiest way possible. Here we can see that the best way to do it was let z equal the parameter, and we labeled that lambda. Okay then, I think that's good enough for 21 then. Great.